morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about modes of transfer. Modes of data transfer. Binary information received from an external device is usually stored in memory for later processing. Information transferred from the central computer into an external device originates in the memory unit. The CPU executes the input-output instructions and may accept the data temporarily, but the ultimate source or destination is the memory unit. Data transfer between the central computer and input-output devices may be handled in a variety of modes. Some modes use the CPU as an intermediate path, others transfer the data directly to and from the memory unit. Data transfer between central system and peripheral may be handled in one of three possible modes: program input-output, interrupt initiated input-output, direct memory access. So the data is in the form of registers. So the data, how we are transferring from source to destination. So what are the techniques, what are the modes of data transferring is the important one. So binary information, the data is always in the form of binary only. So data is nothing but it is in the form of binary, in the form of ones and zeros. So the external device is usually stored in memory for later processing information transferred. So suppose I am taking one CPU, external memory we need for this one. We are connecting memory to the CPU, that is the external memory to the CPU, and these external devices originates the memory in the CPU. The CPU executes input-output instructions and may accept the data temporarily, but the ultimate source or destination is the memory unit. So if we are taking the CPU, definitely we are connecting to the memory, and the CPU connecting with input and output. So CPU to memory, it is externally connected. Input and outputs are the peripherals. Inputs and outputs are the peripherals. So the data transfer between the CPU and input-output devices may be handled in a variety of modes. Some modes use the CPU as an intermediate path, other transfer the data directly and from the memory unit. So some modes use the CPU as an intermediate. So between the input and output, CPU is the intermediate state. CPU is the intermediate mode, and other transfer the data directly to and from the memory unit. To and from the memory unit. So the data transfer between central system and peripherals may be handled. So central system, if I am taking the CPU, it is the central system between the input and output. So this central system and peripherals may be handled. What are the peripherals? Always input and outputs are the peripherals. So these input outputs are the peripherals may be handled in one of three possible modes: programmed input output, interrupt initiated input output, direct memory access, DMA. First one, programmed input output. Programmed input output operations are the result of input output instructions written in the computer program. Each data item transfer is initiated by an instruction in the program. Usually the data transfer is to and from a CPU register and peripheral. Other instructions are needed to transfer the data to and from the CPU and memory. Transferring data under the program control requires constant monitoring of the peripheral by the CPU. Once a data transfer is initiated, the CPU is required to monitor the interface to see when the transfer can again be made. So programmed input output. Programmed input output means arithmetic logic unit is needed, ALU. So CPU also needed. So what is a programmed input output? Programmed input output means suppose we have to give some instructions to the CPU through the input, and when we are executing this program through the output, so we are giving some instructions to the CPU, and this programmed input output definitely we need ALU. So programmed input output operations at the result of input output instructions written in the computer program, each data item transfer is initiated by an instruction in the program. Suppose I have to go move AX comma BX, add AX comma BX int 03. Example I am taking here. So what are the move AX BX, add AX comma BX into 03? I am giving some 3 instructions are there. Maybe I am taking as a program. So the transfer is to from the CPU register and peripherals. So when we are returning the program in the computer program, each data item transfer is initiated by an instruction in the program. Every line I am taking as a one instruction. Here I am taking some 3 instructions are there. It is a one program in a computer, and these instructions I am taking as a one by one. Each line is a instruction, and the transfer is to and from the CPU, register and peripheral. Other instructions are needed to transfer the data to and from the CPU and memory. Transferring data under program control requires constant monitoring of the peripheral by the CPU. Once a data transfer is initiated, the CPU is required to monitor the interface to see when a transfer can again be made. So when the program is initiated through the instructions, the CPU and memory are interconnected. Without a memory, we can't execute this instruction or program. So definitely the CPU is connected with memory, and the transferring the data under program control requires constant monitoring of the peripheral by the CPU. Once a data transfer is initiated, the CPU is required to monitor the interface to see when a transfer can again be made. So CPU is connected to the memory. Program control requires constant monitoring of peripheral by the CPU, and the data transfer is initiated by the CPU. Is required to monitor the interface, see when the transfer can again be made. So it is about the instruction and CPU connected to the memory with input output peripherals. That is a programmed input output. It is one example of data transfer from input output device to CPU. So CPU is connected to the interface and it is connected to the input output devices. So CPU, between the CPU and input output means definitely we are connecting interfaces. Suppose CPU is there and connecting output and input. So these output and inputs are called interfaces. Interface. So what is the use of interface? Means first one we are going for the data transfer. What is the use of interface? Means data transfer between the input to output through the CPU. So what is the interface? Means the interconnection between the input output through the CPU is the interfacing to the CPU. So first the CPU is connected to the interfacing. In the interface what are there? Data register, status register and the flag bit. So flag bit equal to 0 or 1, and status register, what is the status of this one? 0 or 1. So data register is passing the information from input to output through the register, that is the data register. So first address bus, the address bus is connecting through the CPU to input output through the interfacing, and input output read, input output write. So what is a read and a write means? Read means from the computer, write means to the computer. So what is the information we are giving? That is the write to the computer. What is the information we are taking? The data is taking from the CPU. That is called read. So input output read, input output write. It is connecting to the interface through the data register. So input outputs are the interfaces to the CPU. So input output bus means it is working as a input, either input or output. The data is transferring either input or output, and the data valid, data accepted. Data valid means it is from output to input output to CPU. Input output to CPU. That is data valid. Data accepted means CPU to input output. CPU to input output. Data accepted. Input output CPU to input output. It is the input output to CPU. What we are calling input output to CPU is a data valid. So data bus, address bus, input output read, input output write. These are the interconnection of interfacing through the CPU to input output. So these input output devices interconnected to the interfacing input output bus, data valid and data accepted. So it is a data transfer between the input output device to CPU. So interface between the CPU. Interfacing between the CPU. So once program input output is generated, the data register is transferring the data from input to output, and CPU input to CPU, CPU to output. So input output to CPU, what is we are calling, and CPU to input output, input output to CPU, CPU to input output. So we can observe here input output to CPU, that is I am taking as a input output to CPU, data valid, and CPU to input output, that is a data accepted. So it is a flowchart of CPU program to input data. Read data register, check flag bit, flag equal to 1, then read status register, transfer data to memory, operation complete, yes, then continue with program. If no means read the data again from first. So read data register. So what is a data register? I am taking as a data register equal to read. It will be reading the data register. So what is the data is there in the register? It will be read. And check flag bit is equal to 0 or 1. Okay, so check flag bit means if flag equal to 1, then it is going to go to the read operation and then go to exit. If it is 0 means again it is going to the first read operation, again starting. Okay, if flag equal to 1, read status register. Actually read data register, then read status register, data register is readed, and then next go for the status register. If it is okay, transfer the data to the memory. Transfer to the memory. To the memory. If operation is complete, yes, continue with program. If operation is not completed, again going to the first step. So yes, my operation is complete. Then continue with program, next line or next flow, next instruction. If it is process is not completed, it is going to the first. It is a flowchart of the CPU program to input data. And next one is a interrupt initiated input output. In the programmed input output method, the CPU stays in the program loop until the input output unit indicates that it is ready for data transfer. This is time consuming process because it keeps the processor busy neatly. This problem can be overcome by using interrupt initiated input output. In this, when the interface determines that the peripheral is ready for data transfer, it generates an interrupt. After receiving the interrupt signal, the CPU stops the task which it is processing the service, the input output transfer, and then return back to its previous processing task. So after completion of programming input output, we are going for the interrupt initiated. Interrupt interrupt input output means priority will become priority. So first priority which one, second priority is which one. So multi programs are waiting, or multitask is waiting at the CPU. Then we are going for the priority, which priority is first. So in the program input output method, the CPU stays in the program loop until the input output unit indicates that it is ready for data transfer. So when it is in the program loop, input output unit is indicating that it is ready to data transfer. Okay, it is ready for data transfer. So program is executing through the input output and the data transfer is ready for executing. It is a time consuming process because it keeps processor busy neatly. Multiple, suppose one program is there, I need a multiple programs are there. So how can we execute through the data transfer of input outputs? So multiple inputs are there, multiple outputs are there. So how can we executing through the program? So it is some difficult. It is a time consuming process and it is much burden to the CPU. Then we have overcome this problem through the interrupt initiated input output. In this, when the interface determines that the peripheral is ready for data transfer and it generates an interrupt. After receiving the interrupt signal, the CPU stops the task which it is processing the service of input output, then returns back to the previous processing task. So when it is interrupt signal is to the CPU, stops the task which is processing service of input output transfer. So interrupt means multitasking is there. When interrupt is stops the CPU to what is going on of the program, which it is to be processing of the service of input output transfer, and then returns back to its previous processing task. Then it returns back to the previous processing task. Interrupt signal stops the CPU. That means what is the current programming stops and it is going to the previous program, and that previous program will be finished. After finishing of previous, the current program will be run and it will be executed. That is the work of interrupt initiated input output. So when it will be enabled means multiple inputs and multiple outputs or multiple programming is waiting for execution. Then we need priority to execute this one. So when the priority is nothing but a interrupt initiation. Interrupt priority is the interrupt initiating. When the interrupt is initiating, then multitasking. Previous program can be executed. So processor through the data bus. Suppose I am taking device 1, program input and program output, device 2, program input, program output, program input, program output. How many I am taking here? 3 devices I am taking. Each device has a program input and program output like this. So here I am taking these 3. So to the next device, okay? Device 1 to 2, 2 to 3 and 3 to next device, okay? So it is going from here to there. Interrupt, it is a CPU, central processing unit. These devices are connected to the CPU and it is a interrupt acknowledgement. So when interrupt request will become means it is multiple devices are there. So multiple are waiting for this one. Then we are going for the INTR. If INTR equal to 1 means interrupt is enabled. If INTR equal to 0 means interrupt is not enabled. Only one input, one output will be enabled. Interrupt acknowledgement means we have to give some acknowledgement. We need interrupt, or we need interrupt, or we don't need of any interrupt. Suppose INT equal to 1, I have to give an acknowledgement. Suppose INT equal to 0, we have to give an acknowledgement that I need this one. So that is a modes of data transfer through the devices. And direct memory access, removing the CPU from the path and letting the peripheral device manage the memory buses directly would improve the speed of transfer. This technique is known as a DMA. DMA is nothing but a direct memory access. In this, the interface transfer data to and from the memory through memory bus. A DMA controller manages to transfer data between peripherals and the memory unit. Many hardware systems use DMA, such as disk drive controllers, graphic cards, network cards, and sound cards, etc. It is also used for intra-chip data transfer in multi-core processors. In DMA, CPU would initiate the transfer, do other operations while the transfer is in progress, and receive an interrupt from the DMA controller when the transfer has been completed. So, what is the use of direct memory access? It is very, very important and useful for CPU. When removing the CPU from path, no need of CPU. That is called direct memory access. Actually, CPU is connected to the memory through the input and output. But if I no need of any CPU, that means input and outputs are directly connected to the memory. So, removing the CPU from the path and peripheral devices manage the memory buses directly. So, what are the peripheral devices now? Inputs and outputs are the peripheral devices. These peripherals are directly connected to the memory. So, the interface transfer data to and from the memory through the memory, to the memory and from the memory. So, the data transfer from the memory, and a DMA controller manages to transfer data between peripherals and memory unit. So, DMA control will transfer the data through the peripherals and memory unit. Through the peripherals and memory unit. So, no need of CPU. And many hardware systems use DMA, such as disk drive controller, graphic card, network card, sound cards. It is also used for intra-chip data transfer in multi-core processor. In DMA, CPU would initiate the transfer, do other operations while the transfer is progress, and receive an interrupt from the DMA controller when the transfer has been completed. So, when the CPU is connected to the memory through the input and output, so this, when the input is connected to the CPU, it is connected to the memory and it will be execute through the memory, and we are getting the output. But in the DMA, no need of CPU. That means we are disable the CPU. CPU is disabled. That means input is directly connected to the memory, directly connected to the output. So these inputs and outputs are called peripherals. So the memory to memory and from memory, that is the called peripherals. So these DMA as a disk drive controller, graphic cards, network cards, and sound cards, these are the connected to the memory. And the chip data transfer multi-core processor in DMA, CPU would initiate the transfer and do the operations while the transfer is in progress, and receive an interrupt from the DP controller when the transfer has been completed. So When the memory is input to output, then if you need interrupt, it is also initiated. Interrupt also initiated through the memory to execute the output. So modes of data transfer is a three types of data transfers: programmed, interrupt initiated, and direct memory access. So the binary information received from an external device is usually stored in memory for later processing, and the data transfer between central computer and input output devices may be handled in a variety of modes. Some modes use the CPU as an intermediate path, other transfer the data directly to and from the memory unit. So what are the three types of data transfers are there? Programmed input output, interrupt initiated, and direct memory access. So programmed input output means the multiple instructions are executing, multiple program means multiple instructions are executing through one by one. So that is a programmed input output. For this we need ALU, CPU and memory to execute this. And it is a CPU and input output, and between this CPU and input output, the interfacing is connecting to the input and output through the CPU. So we need a data bus, address bus, input output read, input output write. In the interfacing, what is the use of interfacing means? The data transfer between the CPU and input output. That is the data transfer of the interfacing. And the status register and flag equal to 0 or 1. Input output bus, data valid, data accepted. These are the interconnections of data transfer of input output device to the CPU. It is a flowchart of CPU program. Read the data register. If after reading this one, check flag bit, is it 0 or 1? If flag equal to 1, it is going to be executed. That is a read status register. If flag equal to 0 means again it is going to the starting program. If flag equal to 1, read status register, transfer data to the memory, and operation complete, yes, continue with the program. If operation is not complete, it is going to the no. Okay, continue with program means continue with the next program or next instruction. Interrupt initiated means when the multiple programs or priority will become initiated, then we need interrupt. So the programmed input output method, the CPU stays in the program loop until the input output indicates that ready for data transfer. So when the multiple programs are waiting on the CPU to the input output, the data transfer may be some delay due to some multitasking, and it keeps the processor busy. This problem can be overcome with the interrupt initiated. Means if the interrupt we need, then we are going to either INT. Interrupt means INT 0 or INT 1. If the interrupt we need, then we are going for the INT 1. If there is no interrupt means INT 0. And the interrupt signal, the CPU stops a task which is processing and the servicing of input output transfer, then returns back to its previous processing task. It is the interrupt processor data. I am taking here device 1, device 2 and device 3 to next device, interrupt and interrupt acknowledgement and CPU. Interrupt means devices to the CPU. Interrupt acknowledgement means CPU to the devices. Direct memory access means without help of CPU, the memory is directly connected to the input and output. That is called DMA, direct memory access. So what is the advantage of direct memory means? We are not taking any help of CPU. Then the CPU burden is very less and time consuming, and high throughput will become, and the interfacing transfer through the memory is a DMA, and these DMA manages the transfer between the peripherals and memory unit. So no need of CPU means directly the peripherals are connected to the memory and from the memory. So what are the examples of DMA means? Disk drive, graphic card, network card, sound cards, and chip data transfer are the examples of DMA. And the DMA CPU would initiate the transfer, do other operations while the transfer is in progress, and receive an interrupt from the DMA controller, and the transfer has been completed. Okay, these are the references of modes of data transfer. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.